All right, this is game 470, assignment 4. The first problem, we had to create a new shader class that only accepted a single matrix. So that's right here, where it accepts the world view and projection all in one. So then in the main DX app, we have to send it. So we create a matrix, and so we multiply world by the view by the projection here, and then send that one matrix into the new shader. And so here's an example of this running. So it does work. That was all for question 1. Question 2, we had to create 5 different objects and then render them a different color, different position. So we wanted to reduce the number of multiplications. So I sent the view and projection matrix up here on the top, and that's set inside the shader class. And so there's one multiplication right here, and so that's stored. And then from then on, when we send the position, that we send position here, and so we just multiply the world by the view projection that we already have stored. So there's one multiplication. So there's one initial one, and then one for each object afterwards. Let's see. So we can run this. So there's the 5 objects. Question 3, we had to build a new model, and so it was a unit pyramid with a repeated texture on every side. So I chose to do 16 vertices, but for this, I believe you could reuse the same one for the top, so that would get rid of 3. So basically, I'm just repeating the top one 4 times, but in actuality, you could probably only use the same one for each of the 4 sides. Let's see. So that's over here. So we can draw that. As you can see, it's basically the top point is the middle top on the texture or the TGA file itself, and same on all sides, and then the bottom is the full square texture. Alright, so question 4, we had to create a unit box with 6 faces. So that is right here. So different 4 vertices for each side. So there's 24 total. And again, the hardest part was figuring out the exact UV coordinate for each vertex. Okay. Let's run that. So this is the back, right, left, and obviously Z is pointing into the screen. So forward is, or the front is over here. Bottom top. Alright. For number 5, we had to create a new shader texture class. So basically, we just removed everything in the initialization, and then even we added a set texture resource. So basically, after creating a texture, we can set that context within the shader texture itself here. Here's a look at the shader texture class. Basically sets all the buffers, compiles and sets the vertex shader and pixel shader. And so basically we all we have to do in the draw scene is send the camera matrices in the world matrix. And that's it. And so it's the same model as in number 4, the box. For the first further work, it asks to create 3 models with 3 different textures and to use the unit box. So I'll run that. So this is, I played around with the view and the filter and the address a little bit. But what I believe is happening is that each of these is taking the 0, 0 coordinate on the TGA and displaying that. Depending on the filter, it like averages out the pixel, or not pixels, but the textuals around that one point. And so depending on which filter, like this showed up as instead of red, it was pink. And another address, it was lighter. This is a darker one. So again, I can bring up the actual one. So this one is the crate. So for instance here, so I believe it's taking the upper leftmost corner. And then same for the other 2. Like this one, let's see. This one is taking up here, it has a red outline, so that's why it shows up as red. And for the last one, this one, the upper one's white. Alright, stop that. So for the second further work, here's where I set up 1,000 boxes, and we can run this. I'll just skip through this one. So it's almost 250 frames per second, or between 215 and 250. But again, we don't need to set the model context every single time. We can set that once, and then same with the view and projection matrices. So if we take those out of there, it should be better off. And so now it's up over 300 frames per second. So we can further optimize, but we don't even need to set the model at all. It's set up in the initialization up here. So if we run that again, it should be even faster. Probably just slightly though. So we're up to like 240. And again, we can play around further and get further optimized. That's it for assignment 4.